thing is, if you want to save any data, if you want to represent any data in any programming language, the you have to write the data in such a way that the data has an identity. Firstly, every data will have a value, right? Every data is going to have a value. So when I say value, value can be anything. It can be a number. It can be a name. And it can also be a floating point number. Floating point number is nothing but a number that has a decimal floating point values. It can also be a character. Right? It can also be a Boolean value. Every data, every real-time data represents a value. Right? Let us say that if I want to store my salary, let's imagine that the salary is 10,000. So 10,000 is a value, right? So I need to give an identity for this value. So identity is salary or income. I can choose income. Right? So as a developer, right, we can understand this terminology. So we understand the numbers, we understand the identity. But if I want to store the same values and the identity in any programming language, we need to mention that what type of data is it. So this is a type of data which holds integer value. So this int is nothing but this is the data type which is representing this value, or which is storing this value, right? Since it is storing the whole numbers, any whole number in the programming language can be represented as the integer data type. Int data type. Int is nothing but integer. So from this observation, we can say that the syntax is going to be data type. Income is nothing but reference variable from language perspective equal to reference value. Data type, income is reference variable and this is reference value. So this value is real-time data. This is an identity. You can give your own identity. It is not like we have to give only income. You can represent this identity with any name, any meaningful name, right? And when you say this identity in the programmatic language, so this identity is called as reference variable. This value is called as reference value, and this integer is called as data type. Right? So this is how you represent a specific data in a programming language, right? Let us imagine that I'm trying to store two values in the data, right? So this is my program. So this just assume that this program is being developed in C language. So I am representing a sample data like integer a equal to 100, and again integer b equal to 200. Third one is integer like star p1 equal to what, and an integer star p2 equal to, right? This is a simple example that I have taken with respect to C programming language, right? As soon as the compilation starts, after the compilation, what happens? This instruction, while during the execution, this instruction has to get executed, isn't it? So when this has to get executed, for this line, a memory gets allocated. So usually, since we have four data representation, like four integer representation, like we have four reference variable. One is A, one is B, and this one is P1. This one is P2. Okay? So four memory blocks will get loaded in the memory. Right. So for the first instruction, the reference variable is A. Isn't it? So this is going to be A, and this is going to be B, and this is going to be P1, and this is going to be P2, right? So the values are like stored accordingly as per the reference variable. The reference value for A is 100 and it is 200. So you must observe one thing. First two instructions, if you talk about these two instructions, they are just holding a normal reference variable, normal variable in the sense any variable which is not followed by asterisk symbol is called as normal variable. Any variable which is followed by any reference variable which is followed by asterisk symbol, right? This is the asterisk symbol, right? Any variable, what I'm trying to say is, any variable that is preceded by asterisk symbol. This variable is called as pointer variable. Right. So what this pointer variable usually does, it is going to store the address of a normal variable. So you look at this line exactly. If you look at this specific line, you look at this. We are using address of operator followed by the reference variable here. It means this P1. This P1 is going to store the address of A. So for each memory blocks, there will be an address assigned by the system. Let us imagine it is 1, this is 102, this is 103, and this is 104. Right? So P1 is going to store the address of reference variable A. So this P1 is going to store what? This is going to store the address of A. So if you talk about address of A, the address of A is 101, isn't it? So this is going to store 101. When I say P2, again, if you look at P2 is going to store address of P. So this is P2, right? This P2 is going to store address of P. So address of P is 102, right? So here it is going to store. So from this we can understand that a pointer variable is going to store the address of a normal reference variable, right? So we can come to this conclusion from this diagrammatic illustration. Here the conclusion, how the conclusion is going to be. The normal variable is going to store a normal value. The pointer is also a variable. Is going to store the address the specific variable. Or we can also say that, or any normal variable. Right? So if you get a question like what is a pointer, and if you were asked something like how pointers are applicable in Java, your direct answer should be pointers concepts is not applicable in Java. Pointers are concept that is available in C and C programming language. A simple answer. This is a simple answer that you are going to give. The pointer is a Pointer is a variable which is going to store the address of the specific variable or any normal variable. Right? Normal variable is something which will store normal value, but the pointer variable, when you say a variable as pointer, it is going to store the address of any normal variable. Right? These are the pointer variables. They are not actually storing the values. It is storing the address. Address of what? Address of the normal variables. Right? So if you talk about AND operator, you can call this as address of operator. Address of operator. Right? So this is how it can be called, and we can call this as asterisk symbol or indirectional operator. Direction operator. Right? So there is a problem in the pointers concept in C programming languages. What is the problem? We will understand that. For example, let me write a small code. Let me write it here only. So if I had to save a confidential information, for example, let us say that our ATM PIN number is confidential information. You cannot share that number to anyone. Right? Or something like, now forget about ATM number. If you want to save our Aadhaar card number is also confidential. Right? So let us say that I am saving an Aadhaar card number inside a reference variable called Aadhaar. Let us say that the Aadhaar card number is 1234, right? For simplification is 1234. So Aadhaar card number is a long number, but for simplification I'm taking it as 1234. Right? So in C and C++, right, if this number is set as private, private means something which we cannot access. So what I'm trying to say is, if you declare any variable as a private, it means it is something very confidential. You won't get any privileges to access this particular reference variable. You cannot access this. Once you declare this variable as private, you cannot access this and you cannot perform any modification. Right? We will discuss about this in future. For the time being, private is something that will make sure that the information that you are giving or that you are declaring is very confidential, and accessing to this variable, I mean, you can access to these variables, but you cannot perform any modification to this variable. Modifications are restricted, right? But in C, what happens? I cannot access. I may not be allowed to perform any modification for this variable, but indirectly, I got an option. What option? I can use a pointer. I can use the pointers concept. Let us say that I am taking a variable p. It is not only p. You can take any variable. It can be like a. It can be like b. It can be like c. This reference variable, pointer reference variable, can be anything. So since it is a pointer, I am taking its first character, which is p, equal to. First, what I will do, I will try to get access to this address. How to get access to this address? I will use this operator. Which operator? Address of operator. And I just as soon as I got this address reference, it means I got access to this value as well. So internally, what is happening? The memory get allocated, right? So the memory inside this memory block 1, 2, 3, 4 will be saved, and this is nothing but what? This is Aadhaar. Right? And again, I am using this address of operator. I am using a pointer. So the value of the pointer is the reference variable for this pointer is p. Right? So this p is storing what? This p is storing address of other. Right? For other, in the memory block, each and every memory block will have an address. Will have a random address. It can be 1 or 2. Any numerical value will get assigned to the specific memory block. We usually refer it as address. So with this pointer concept, I am trying to get access to this address, other address. So this other address of other will be saved in this pointer variable. And again, this pointer variable is going to have its individual own address. Let us say this is 104. Right? So this pointer variable indirectly got to know about the address. From this address, it can get this value. Like here, the security is compromised. Right? We are unable to, make sure that this particular variable is completely private. It may look like it is a confidential information, but I am able to get access to this confidential information. Getting access to this information is just like a cakewalk for C programming, a cakewalk for pointers. Right? It is violating the confidentiality. It is violating the actual purpose of private variable. Private means strictly it is a private. What does it mean? No one can get access to this, and no one can make any changes. Right? So pointer concepts are indirectly getting access to this private variable, and they can able to make changes. Once they get access, they can able to make changes. Right? So what Java says, so this is what Java says. Java says the pointers are not included just because of security reasons. Because it is compromising the security. Right? So you can add this point. So the question could be like this: pointers are there in Java. You can just say pointers are not there in Java, and the first answer can be the pointers are not included because of security constraints. Right? Because in C and C++ language, the security is getting compromised, and the data security for the particular data is getting compromised. It can be easily hacked in the sense indirectly you are able to get access and to see this information. Let us say in the real time example, in our college, since you are a student, you will be given a roll number for your identity. Right? Each and every person is not going to have the any unique name. So sometimes the names are duplicated. Right? If you look at any classroom, you can see at least one person with two persons with similar names. If you take my name Balaji, if even in my work relation, there are many people in the name of Balaji. So I cannot make Balaji as a unique identity. So what they do, they generate an employee number. Right? So with the employee number, they get to know if they are speaking to the right person, if they are speaking to the right Balaji, or if they are communicating to the right Balaji. Right? So in the a name is not a fixed identity, right? To take any name, multiple people can have the same name, right? But what they do in even in colleges, even in schools, they just generate a particular identity in the name of roll number or in the name of employee number. right? Let us say my name is Balaji. So they just don't communicate with, I mean, if they want to communicate with me, they just don't communicate with me with my name. Instead, they communicate to me with my, mobile number, because my mobile number is fixed. My employee number is also fixed. My email address, my email number is also fixed, unique ID. Right? So they get they get any of this information and they can communicate to me directly. I mean, what we call it as to the correct Balaji, because in my employment, in my office, there can be many persons with the same name. And this is what defines the specificity, right? So they can track me with the help of my phone number. They can track me with the help of my employee number. They can track me with the help of my email ID. Right? They are getting access to me. One is with phone number, second one is with employee ID, third one is with email ID. And the fourth one is they can also get access to me with address, with my address. Right? 4 ways they have access to me. Hope you're able to understand this point. If I apply this scenario in C, to apply the same concept in C, this particular value, this particular secured value can have access through pointer, can have an indirect access to the pointer, right? So the security is compromised, because even though we make this particular variable as private, right, somehow it is the C program as a loophole. We can call it as a loophole, right? Hello. Hello. Am I audible now? I think we had a network disruption. Please.
Yes, sir.
Okay. Please type yes in the chat box if everything is clear till now. If you have any doubts till now, still a long way to go for the pointers. Okay then. Let's continue. So this is what the pointer is in C programming language. We have discussed all this in the C programming language, but our question is what? Our question is why pointers are not available in Java. So we got to know what is pointer. Now this question is clear and the answer is also clear. Okay. And the next question is why pointers are available in Java but it is not used in Java. It is available, I mean, why pointers are available in C and C++? It is available in C and C++. But the problem is that pointers are what? The pointers are compromising the security. Right? So what happened is this is the cycle, this is the time period. When you talk about the time period, we already know that C was introduced in 1969, C++ 1983, and Java is 1996. Official version was released in the year 1996. So 1969, 83, 1996. So C was introduced here, C++ was introduced in the year 1993, and Java was officially introduced in the year 1996. Right? So in 1969 and 1983, the C and C programming languages. So if you see if any new mobile phone getting introduced in the market, what they do actually, they will make sure that the new mobile is going to have some new features. At the same time, they will also make sure that this new mobile is going to eliminate the disadvantages that it has in the previous versions, right? Whenever, for example, if you take iPhone is going to improve its features. Improving the features means what? It is going to dismantle some features or eliminate some features that performs that is lacking performance, or what, that has some security constraints. The new features is going to have a new iPhone is going to have new features, and the old some kind of versions or some kind of internal features are going to get eliminated because of the drawbacks. Same thing. So when Java was being developed at the time, they thought pointers concepts was something that needs to be ignored because it is compromising the security, and it is being a the pointer concept is being a loophole to get access to the valuable information, right? So the concept that was included in C and C++ was eliminated in Java. They removed what? They removed pointers concept. But secondly, if you also see the C and C++ are platform dependent programming languages, right? So platform dependent is also something that is not a good feature, right? Because platform dependent is you can write, you can develop, and you can execute, you can compile, and you can execute the same code in the same machine. So what Java did, they have also made sure that this platform dependency is also getting what address. The question of platform dependency is also getting addressed. So what they did, they made sure that Java is a platform independent programming language. So you can write program on one machine, compile on one machine, and you can execute it on different machines. Let us say that Windows, Linux. Next one is what? Mac. Right? So they removed pointers. They introduced platform independent concept. And the third one is architecture. It is not, C and C++ are not architectural neutral. Right? So Java people has addressed this issue also. They made Java languages architecture neutral. Architecture neutral. Sorry for the spelling. Architecture neutral. Okay. So what they did, they eliminated the pointers concept. They made sure that the Java programming languages is going to achieve platform dependent concept, and they have also addressed this architecture neutral concept. Right? Because of these concepts, Java has become simple programming language. Java has become simple programming language only because the complexity or complicated things are ignored, eliminated. Even though Java is not simple, we call it a simple. Why? Just because the complexity part has been eliminated by Java. So if Java is simple, it means that C and C++ are little complicated, isn't it? Right? When you get a question like why Java is simple programming language, your answer should be in such a way that you have to address the question of pointers, you have to address the question of platform dependency, and you also have to address the question of architecture neutral in comparison with C and C++. Right? This is how the answer should be for why Java is a simple programming language. You have to include all these three concepts. Then the interviewer will be impressed. Right? And if you ask me, still we are discussing the pointers concept. The pointers concept is not yet completed. There is a long way to go. Before that, I just want you to tell me if you have understood the concept till now, so that we can continue further. I mean, type yes in the chat box. You don't want to, if you are unable to follow, I can keep it little slow. Either one, it's up to you. If you are under. Hello. Actually, I was speaking on mute till now. No one has informed me. Let me repeat it. Am I audible now?
Yes, sir, you are.
Actually, actually, I was speaking on mute till now. You might have
Okay.
no one has informed me. Okay, I was just telling what I was saying is, you look at the time frame. C was introduced in 1969.
Sir, your screen is not visible, sir.
My screen is also not visible. Okay, now I hope it is visible now.
Yes, sir.
Okay. Yeah, I was saying like Java. I have just taken the time frame, but you have please make sure that till here it is. I have discussed till here, right? Because I was speaking on mute for a long time without sharing the screen. Hello?
Yes, sir, we finished it.
Till okay, okay. So what I was saying is C and C++ and Java, they were introduced in this specific time periods. One is 1969, second one is 1983, and third one is 1996. Right? So what happened when they are introduced this concept? Let us take a simple example, like let us take a mobile phone. Whenever the new mobile phones are appearing in the market, what they actually do before introducing any new mobiles, they will make sure that the features that are disturbing in the previous versions are eliminated, and they will add some new features in the new mobile phones. Whatever it is, if you take Samsung, every time they are going to introduce a new feature. The mobile is going to be a little bit expensive. Even if you take iPhones, every time they are going to introduce a new feature, and the iPhone is also going to be very expensive, right? So same thing they did for same thing they do for languages as well, right? So in in C and C++, they have found these three concepts. One is pointers, second one is platform. C and C++ are completely platform dependent, and it is completely architectural neutral, right? So they have Java people what they thought. Java people are like they have to make the Java programming language as they have to keep the programming language as simple as possible. For that, what they did, if the Java needs to be simple, it should eliminate the complicated topics. What is the complicated topic? One is pointers or complicated topic. Because pointers are what? Pointers are a threat to the data. It is violating the security. I mean, it is compromising the security. So pointers concepts are there in C and C++. If any new programming language is getting introduced, they will address the drawbacks of the previous programming languages. They took C and C++ an example. They not only C and C++, many languages are there that has pointers. What they thought, if the pointer concepts are removed, the programming languages are going to be little simple. So Java people has considered this pointer concept, and they made sure that pointer concepts are not applicable in Java. First thing. The second thing is, if you see C and C++ programming languages, they are platform dependent. Why it is platform dependent? You can write program in one system. You can compile this in the same system. You can execute this in the same system. Right? If I am writing it in the Windows system, the compilation should also be in the Windows system. You can execute this program in the Windows system. This is called platform dependent. Right? So Java people thought, so somehow we need to. They were like, okay, this concept should be considered, and we need to give a new future for this dependency. So they thought they introduced the platform independency concept. Right? What platform independent concept means? Same thing. Write the program, write W or write once, run anywhere. Write the program, compile the program on the same machine, and you can execute this program on different machines. Just like that, you can execute it on Windows, execute it on Linux, you can execute it on what? Mac. So they have addressed this, our people, right? So they have addressed two things. One is a pointer, third one is architecture neutral. C and C++ are not architecture neutral. They are not architecture neutral. right? And they made sure that Java should get Java should be developed in such a way that it's going to be architecture neutral. What is architecture neutral? Once again, architecture neutral is nothing but if we have any platform is a combination of hardware and software. We know that we have discussed this already. Platform is a combination of what? Hardware and software. If you make any changes to your hardware or if you make any changes to your software, right, the Java program is not going to get affected. Your Java program is designed to consume 10 MB of MB. It is going to consume the same amount of memory even after making the changes in your hardware. That is called as architecture neutral. Whereas in C and C++, if you perform any changes to your hardware, the memory consumption will be varied. It could be 10 MB before making changes, but it could go to 15 MB after making changes. You cannot guarantee the performance of the memory. This is why Java has become, we call the Java programming as a simple programming language. Only because of this. Only because of what? Java eliminated pointers concept. Java introduced a platform independent concept. The Java has made sure that the language is going to be architecture neutral. Even though I'm saying Java is not simple, but it is simple than the previous programming languages, just because it has managed to eliminate this pointers concept and this dependency concept and this architecture neutral. It has addressed this architecture neutral. In future, if anyone is asking you why Java is simple programming languages, we cannot just say that Java is simple because it is simple. No, that should not be answered. The answer should be Java is simple because it has no pointers. First point. Second point is it is a platform independent programming language. Third point is it is architecture neutral. Right? If you ask me, okay, sir, these things are good. Okay, no issues. What about the pointers in Java? Right? If you have understood the pointers, what is the concept of pointers in C and C programming languages? We are good to go now. We are good to see why it is not applicable in Java. Just type S in the chat box if you have understood till now. And once again, if my screen is not visible or if my voice is not audible, because I cannot confirm it, right? Any one of you can tell me, or you can unmute yourself and you can tell me it is not audible or it is not visible, right? Because I am under the impression that the class is going on. Okay. So let me save this part, then we will go to now we will discuss. So this is very important topic. Why pointers are not available in Java. The first point is what it says actually. Why it is not available in Java? We will see that, right? What it says, pointer variables require static memory allocation. But Java is a dynamic programming language. That's why pointers are not allowed in Java. But there is no justification for this point. Okay, so I will explain you what it means actually. What the definition says actually, I will explain you in detail. So point says pointer variables require static memory allocation, but Java is a dynamic programming language. Right? So we already know what is static memory allocation. Any memory that is getting allocated during the compilation time. Memory allocation happens in the compilation time. It means at the time of compilation, the memory gets allocated. So only C and C++ programming languages get get its memory allocated during the compilation time. So we have discussed all this. If you go back to our classes, if you see our fifth class notes, fifth class in the sense the count I'm talking about, the number fifth class, you will see the justification for this point. So C and C++ they are during the compilation, the memory gets allocated. For Java, during the execution, the runtime memory. Java supports runtime memory. C and C++ support compile memory. Again, we will discuss about this in detail now. So what happens is, just assume that we have a RAM. This is just assume that we have some blocks of memory inside a RAM. Let me quickly draw the diagram. Just imagine that this is my RAM size, okay? Before proceeding to this, let us imagine that I have developed a program in my system. I have developed a C program in my system. This program has a simple logic in C language. Let us say that I am going to take two variables. Right, the variables are going to be like integer a equal to 100, right? And I'm going to take another pointer variable, integer string pointer equal to address operator. Okay. So this is the program that is developed using C programming languages, so that the extension of the file is .c. Right? So once the program is written, the first stage of the program has to go to the compilation stage, right? We have seen this already. Every program must go to the compilation stage. So this is a stage of compilation. What compilation? The compilation? We have a compiler. What this compiler does? Compiler is going to check whether this program has any errors. If it has any errors, it's going to throw that error. and we have to fix that error, and we have to compile it once again, right? That's the job of compiler. So see what C language does. During the compilation, it is going to allocate the memory. For what? It is going to allocate the memory for instance variables. What we call it as for variables that we are defining. So in C and C++ programming language, memory gets located during the compilation. So remember this point. So during the compilation, the memory will be allocated. So where the memory gets allocated in the memory area, right? So if you observe this memory area, just imagine this as a RAM, simple RAM, a very small RAM. Okay, the RAM was this RAM has only 8 blocks of memory. For the imagination purpose, I have taken this as RAM because I have a little size, right? Mine is a small RAM, right? So again, the every RAM will internally get divided into many memory blocks. So each and every block represents a represents 1 byte of memory or 2 byte of memory. Like any byte, you can imagine any byte. But each and every block is going to have an address, right? So let us say that this block, first block is going to have the address number as 101, and this is going to have as 102. And the sequence will go on 103, and this is going to be 104. Right, again, this is going to be what? 105, 106. The sequence goes on. I don't want to, it's self-explanatory. The sequence goes on, right? So when I say integer a equal to 100, this 100, in which memory block it will choose? It is not our control. When we say a equal to 100, the programming language can choose any block of memory. It is not fixed. We cannot say that it is going to choose this specific block. It is not like that. You can choose any block out of this. Randomly, it is going to choose the blocks. Let us say that it is going to choose this block. Or we can say let's using 104 block. 104 block. Right? What is the value inside the A? The value is already defined as what? 100. So for this instruction, it has chosen this block, and its value is going to be 100. And the reference variable is what? The reference variable is A. If you look at the second instruction is a pointer variable, right? The pointer variable in the sense it can choose again. Its second variable can choose any block. It is not fixed. Can choose any random. Let us say that it is choosing this block. Right? So what it is going to store? Since it is a pointer variable, it is going to store address of A. Address of A is what? 104. Right? So it is going to choose. It is going to say 104, and this is a what? This is a pointer variable which is #p, and it has its own address. 101 is its address. This is how it gets executed, right? So what I am doing, if I try to run the same program, just imagine that this is the Windows operating system. But try to run the same program by choosing a different operating system. So now I am going to choose a different operating system. I'm going to run the same program. So second time, just imagine that I have chosen an operating system called Mac operating system. Okay. So just imagine that this is a Mac operating system, not Windows. Now this time, writing the program in the Mac operating system. So Mac operating system, in the Windows operating system, the memory blocks are chosen according to the programming language. But in the Mac operating system also what happens? Same thing happens. It's not guaranteed. What? It's not guaranteed that it is going to choose the same memory blocks. Must understand that. Second time, this may choose two different memory blocks for these two values. In this case, it can choose this block and this block. The Mac operating system. You cannot say that it is going to choose the same operating system like it has chosen in the Windows operating system. This time it is going to be different, right? And the third time, if I try to choose Mac Linux operating system, for the same integer a equal to 100 and pointer variable which is storing address of a, this time the system may choose two different memory locations. What I am trying to say is that the memory locations are not fixed. In this case, it can choose these two different memory locations. So this is what the static memory means. Static memory allocation is when you write a C program and when you try to do the compilation in the same operating system, the memory that the variables are getting chosen by the programming language can be any random memory blocks. You cannot expect the same memory blocks in the Mac operating system. Mac operating system, these memory blocks are going to be different. So the conclusion is something you must observe. What is the conclusion here? You see the a equal to 100. The a value is going to be 100. There is no doubt about it. Imagine there is a, right? But if you talk about this pointer variable, right? Pointer variable is going to store the address of what? Address of a variable. So now this time, second time, when the system is when the program is running on Mac operating system, this memory block can be 112. This time address is going to be this is going to store 112. Previously the address was 104. This time the address is 112. Right? And it is going to have its own address. Let us say this is at 106. Right? If you understand this pattern, again the third time we are running it in the Linux operating system. So let us say the Linux is choosing the this memory as a, right? And here this is as a pointer variable, because we cannot specify that it is going to choose the memory allocations are completely random. It is not under our control. This time just we are assuming that it is going to choose this location, pointer variable. So this pointer variable is going to store the address of a. So let us assume that the address of a is 105. So this will store the address as 105, right? And this again this address is going to be 112. If you see values for reference variable is going to be same at any point, any system, any operating system, right? Here also it is 100, and here also it is going to be 100, right? But the address is going to change with respect to each and every operating system in C programming language, right? I'm not telling anything. I'm just saying compilation. After the compilation, compiler allocates the memory in the RAM, in the memory address. This piece of memory will be allocated for each and every operating system for the same programming language and for the same code, right? So if you look at Java, if you apply the same concept in Java is not going to allow pointers. But what if it is going to allow pointers, and what if you try to apply the same concept in Java? If we understand that, the pointers concept will be crystal clear. Just type yes in the chat box if you have understood the explanation from here. I have just explained it, right? I have just explained what is static memory allocation. And static memory allocation is something the memory gets allocated during the compilation. C and C++ follow static memory allocation. What does it mean? Whenever you're trying to run the program in each and every operating system, the memory gets allocated during the compilation time. The values of pointer address is going to be different for each and every operating system. For Windows operating system, it is going to be 105. For Mac, it is going to be 106. For Linux, it is going to be 112. Right? So what actual difference it is going to make when we are trying to apply the same concept with Java? Java will create a lot of problem if you follow this concept. We'll discuss this tomorrow. Just try to hit the type yes if you have understood till now, so that we can continue it tomorrow. Yeah, this concept is little lengthy and is going to take at least 2 to 3 days to completely understand what is pointers. No worries. People will say Java is very difficult to learn. It is not like that. Java is a very simple programming language. The only thing is we need to maintain consistency and we need to put little efforts. Because Java is designed for humans. So it is not as complex as it is getting portrayed outside. Don't worry about this. These are the theory concepts, because once these concepts are over, once you get used to programs, these basic fundamentals are going to help you a lot. Okay, till that, show some patience. Write the notes the very same day. Right? You can come back. You can get back to me if you have any doubts through the email, or you can contact me over the phone. Right? But try to complete the task, not the task. Complete the notes on the very same day or before coming to the next class, so that you will get some confidence.